Okay, we want to find a systematic way to get the current in the circuit, in this circuit. And we're going to do it in a very systematic way. Of course, when you solve problems, you're not going to do it this way because it's very long, but it's good to know this way. If you ever get stuck and you want to go back to basics, this is the way you should do it. We can name points across each element. So we'll name this point A, we'll name this point E, we'll name this point B, name this point C, name this point D. And we'll do something in a very systematic way. We'll get VA minus VE. And we know that that's just epsilon. We did this before. And then we'll get VE minus VB. We know that the current goes from high potential to low. So the point E is at a lower potential than point B. So VE minus VB minus IR. Then VB minus VC. This is an ideal wire, so there's no potential difference between B and C, so this is just 0. And then we'll get VC minus VD. Now, current goes from region of high potential to low potential, so point C is at a lower potential than point D. So that means VC minus VD is a negative number, minus IR. And then we'll get VD minus VA. And VD minus VA is the potential difference between 2 points for an ideal wire, and there's no difference in potential between A and D. An ideal wire has a 0 resistance, so VD minus VA is 0. Look at the way we've done this. I got VA minus VE, and then VE minus VB, and then VB minus VC, and then VC minus VD, and then VD minus VA. I did it in a very specific way, going from here to here, and then 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 from here to here. When you do it this way, the minus VE cancels with the VE, minus VB cancels with the VB when you add them, and minus VC cancels with the VC, and minus VD cancels with the VD. And when you add everything, the VA here will cancel with the minus VA here. So the left-hand side, when you add all these to each other, the left-hand side becomes 0. And the right-hand side, then, you just add what's on the right-hand side. You get epsilon minus IR minus IR. So this is a very systematic way of finding the loop equation for a circuit. So once you have this equation, you can rearrange the terms. You get epsilon is equal to I times R plus R. And that gives you that the current is equal to the EMF over R plus R.